We're going to do this the slow way, because the fast way is how people end up arguing about pixels. Over 2 consecutive nights, astrophotographer Ray records a set of images he attributes to Comet 3 Atlas. The key detail is not that he saw a comet. Lots of people image comets. The key detail is what he says becomes visible only after he changes equipment and then reduces, rather than increases, the amount of visual information in the frame. According to Ray's observations, the raw frames show something that looks simple at first, an elongated central shape with smoke-like emission and jets. But when he removes noise, applies one controlled sharpening pass, and then progressively reduces brightness to strip away the coma, the internal structure becomes more complex, more directional, and, in his view, more difficult to reconcile with what he expects a typical solar system comet to look like. That's the claim. The job here is not to accept it or reject it emotionally. The job is to separate 3 things. What Ray actually records, what Ray infers or suggests, and what remains unknown because it is not measured. So let's start with the data in Ray's own order of operations, but not in his storytelling style. Ray says he spent most of the night imaging and that he has images from 2 nights, last night and the night before. He also gives a clear time range for the best sequence he wants to show, from 0 inches the morning till 6, 15 inches the morning, roughly 3 hours of imaging. That matters because 3 hours is long enough to compare sequential frames, not just a single snapshot, but it's also short enough that you cannot learn everything you want about a moving object. You can see changes, you can see repeatability of features, but you cannot easily prove what's intrinsic to the comet versus what's produced by the pipeline by tracking or by viewing geometry. Ray then introduces a second key detail. He changes hardware. He says he realized that I need a bigger scope. He explains he had been using one scope for a while, but after seeing more structure, he wanted more detail. He ended up getting this big one and made it work. This is the first pivot in the story, because anytime the instrument changes, the data changes with it, resolution changes, contrast changes, sensitivity changes, and that can reveal real structure, but it can also reveal artifacts that were previously invisible. Ray captures this when he frames the reason for switching telescopes as a response to seeing more structure and wanting a bit more details on that structure. That is a rational motivation, but it also raises the first question we have to hold in mind. When the structure looks different, how much of that difference is the comet and how much is the instrument? Now, let's mark what Ray actually does with the data after he captures it. He shows what the images look like directly from the camera. His description is consistent. He says it looks like a elongated ball with jets and smoke coming out. Then he describes what happens after processing. He removes noise and sharpens once a single sharp, and he says he was surprised because removing the noise will change the picture from what it was like showing like a small elongated ball to all this. He describes so much data that is buried inside that this is a crucial point, and it needs to be handled carefully. Noise reduction is not a neutral operation. It is an algorithmic interpretation of the image. It can reveal signal, and it can also shape signal. If you push too hard, you can create structure that looks meaningful. Ray claims he did a minimal process, noise removal, and one sharpening pass, and then he chooses to reduce brightness to focus on the core rather than the surrounding coma. Ray explains his processing here when he describes exporting frames, reducing brightness, then reducing it again, and then again explicitly to see what's inside the coma. He is not aiming for a pretty picture. He says that directly. He says, I'm not interested in making a beautiful picture. I'm interested in seeing what it is. So what does he say he sees? First, multiple jet-like features in different directions. Ray points to jets here, and a jet here, and a jet here, and a jet here, and he repeats that pattern, emphasizing it's not just one direction. Second, he notes a spike that he says is a star behind the comet. That matters because it is a reminder that at least some sharp features in the frame are unrelated background objects, and without careful tracking, you can confuse a star with a structural element. Third, he emphasizes that the fuzz around the core is the coma and not atmosphere. That is not a measurement, but it is a statement of interpretation. He is trying to clarify that what we're looking at is close to the comet's immediate environment, not just Earth's seeing conditions. Fourth, and most central to his argument, he claims apparent rotation or internal motion. He says that when he reduces brightness to focus on the core, it looks weird, and that you will see the rotation. He then explains that because the object moves quickly, he cannot just play the time lapse in the normal way. He says he has to do comet alignment so the comet stays in one place and the stars move. He does that and then claims the rotation becomes clear. This is where the investigation lives. If the comet is held stationary by alignment and the stars drift, that can support the idea that the motion is real within the comet and not caused by the mount. But it can also amplify processing artifacts. Because alignment itself involves interpolation, it remaps pixels. That can introduce repeating patterns, especially when combined with brightness manipulation and sharpening. So in Atlas style, we accept, but we pivot. Yes, comet alignment is a legitimate method for examining nucleus region structure across frames. But alignment plus aggressive contrast changes can also create misleading internal motion patterns, especially if the object is faint and the signal-to-noise ratio is low. Ray's claim is not automatically wrong, it is simply not settled. Now we insert Ray's own words at the key beats, as raw source clips, without turning his voice into our conclusion.
So I completed taking pictures of Comet 3 Atlas last night and the night before. I pretty much spent most of the night taking these pictures, and I realized that I need a bigger scope. So I was using this scope for a while, and all my pictures are from the other one. But as I saw more structure, I wanted to get a bit more details on that structure. So I ended up getting this big one, and painstakingly I made that work, and finally I got some pictures. And
Back to the evidence. Ray is not claiming a single frame is decisive. He repeatedly emphasizes sequences. He says the features persist across individual images, each being 60 seconds each. He describes stepping through frames one by one. He describes running time-lapse at different speeds. He describes the structure as becoming more and more prominent. These are all observations about consistency. Consistency is important, but it does not alone tell us what the structure means. Now, Ray also adds something else. He talks about bias. He references the black hole image from about 10 years ago, describing the method of testing reconstructions with unrelated images to make sure engineers were not forcing a black hole into everything. The point he is making is a good one in spirit. If you go into the data expecting a spaceship, you will see a spaceship. If you go into the data expecting a comet, you will see a comet. But we have to separate the philosophical point from the observational data. Ray is correct that bias exists, but saying we should stay unbiased does not itself validate any particular interpretation of the features. The only thing it does is establish a goal for how to look, and we will keep that goal. Now let's define what mainstream comet physics would expect. Comets often show jets. Jets can emerge from localized active regions. They can appear in multiple directions because the nucleus rotates and because material responds differently depending on illumination. Comas can look turbulent. In long exposures, gas and dust can form layered structures and filaments. Apparent rotation can be real, a rotating nucleus with jets, or it can be a projection effect caused by changing viewing geometry. So on paper, nothing Ray describes is impossible. But Ray is not simply saying, I saw jets. He is saying that when he reduces the brightness to almost nothing, the core reveals an occupying something, an elongated structure in between and motion that he finds hard to explain. He also emphasizes that the raw image looks simple, while the processed image looks structurally rich. That is the opposite of what casual viewers expect. Most people think processing adds beauty, not hidden complexity. So the except but pivot here is this. Yes, processing can reveal real faint detail, but it can also reveal processing behavior. So we need to ask, what do we not have? We do not have calibrated photometry, so we cannot say how bright the jets are relative to the coma in physical units. We do not have spectroscopy, so we cannot say what gases or dust dominate the emission. We do not have independent replication from another observer with a different instrument and pipeline. We do not have a quantified rotation rate. Ray does not measure period or axis. He reports the appearance of rotation. We also do not have the exact settings of the noise reduction method or sharpening kernel. That matters because different algorithms can create different kinds of ringing, edge, enhancement, and perceived motion. This is not a criticism of Ray. It is simply the boundary of the data. Now we go back to the second clip, which establishes the raw morphology before the heavy interpretive steps.
It looks like, if you just take a look at the pictures directly from the camera, it looks like a elongated ball and some jets and smoke coming out. That's how it looks like. Looks like the elongated ball. And it keeps going up and down. Now, I took this data, I removed the noise, and I sharpened it once. I'll show you that very quickly. So now we have the pictures without noise and now we have the pictures without noise and sharpening, like a single sharp. And this is
Now, the third clip is about the claimed internal rotation after alignment. This is the core contradiction Ray leans on.
looks like this. This is very short. So obviously, after looking at all that, I had an idea that I don't want to do comet alignment first. I went ahead and exported these pictures. I reduced the...
Now we're going to step back and do the hard part, the part that annoys both skeptics and believers. We are going to outline the strongest contradictions without inflating them. Contradiction 1 is motion. Ray implies the internal structure changes in a way that suggests rotation, while the object is held fixed by alignment and the stars drift. That argues against simple Mount jitter, but it does not exclude processing artifacts or subtle residual misalignment within the comet's coma structure itself. Contradiction 2 is directionality of jets. Ray describes multiple jets in different directions, not a single dominant outflow. That can happen naturally, but the combination of many jets plus a strongly elongated core appearance can look unfamiliar compared to the common public image of a comet, which is usually a smooth coma and a tail. Again, unfamiliar is not impossible. It just means we should test. Contradiction 3 is visibility through subtraction. Ray sees more structure as he reduces brightness that might indicate real high contrast features near the core hidden by the bright coma. But it could also indicate that the processing pipeline is amplifying edges and creating perceived structure as the surrounding brightness is suppressed. So what are plausible natural working theories without pretending we've solved it? Working theory 1 is a rotating nucleus with asymmetric outgassing. A rotating nucleus can produce jets that appear to move in a sequence, especially if different active regions turn in and out of sunlight. In a time lapse, that can read as spinning structure. Working theory 2 is that the apparent structure is a projection of jets through a dense coma, with the viewing angle making the core look elongated. When you reduce brightness, you remove the diffuse halo and reveal the sharper inner region. That could make the object look more mechanical than it is. Working theory 3 is that the observed internal motion is partly real and partly pipeline. A faint object near the limit of resolution can generate false motion under alignment and interpolation. A slight shift can look like rotation when you play frames quickly. All of these are plausible. None are confirmed. Now, what Ray speculates about origin, whether the object is technological, living, from another galaxy, or something else that belongs in a separate category. Ray does say, we don't know, and he encourages neutrality, but he also suggests possibilities that go far beyond what the images alone can support. So we keep the separation. Ray observed structure that he finds unusual. Ray assumes it may not resemble typical solar system comets. Ray speculates about non-standard origins. What remains unknown is almost everything you would need to settle those origin questions: composition, dynamics, and independent confirmation. There's one more important detail Ray provides, and it's subtle. He notes that the raw images show turbulence and gas dispersion when brightness is not reduced, especially in stacked images. He explicitly says stacking can produce the look of a jet trail because gas released across frames accumulates. This is correct in principle. Stacking shows integrated behavior over time that can hide fine structure but show broader features. Ray says he is not interested in stacking for beauty. He wants the core. He reduces brightness to isolate it. That is a coherent investigative approach, but it also means the final image, he emphasizes, is heavily dependent on subtraction. That is a fragile method if you don't have calibration. So what would a careful next step look like based on publicly known best practices? 1. Independent imaging from another observer, ideally with different optics and a different processing pipeline, to see if the same core morphology appears. 2. Keeping a copy of the raw frames and documenting exactly which noise removal and sharpening settings were used so others can reproduce or challenge the processing. 3. If possible, spectroscopy. Even low-resolution spectroscopy can tell you whether the emissions align with typical cometary molecules. 4. Quantify the motion. If Ray believes rotation is present, estimate a period by tracking the repeating pattern across frames and timestamps. None of that requires assuming a conclusion. It only requires treating the images as data rather than as narrative fuel. Now we come to the ending, and we do not resolve what cannot be resolved. According to Ray's observations, he has captured what he considers his best images yet, spanning hours and 2 nights, and he believes those images show multi-directional jets and apparent internal rotation that becomes clearer as he strips away the coma and holds the nucleus in place through alignment. That is the claim anchored to his footage. What we can say, without overstepping, is that the sequence demonstrates how quickly perception changes when you change instruments and processing choices. The same object can look like an elongated ball with smoke in one frame and a structured rotating core in another, depending on how you treat the signal. That's not an argument for or against anything. It's a reminder that the sky is not just observed, it is reconstructed. The open question is simple. Are we seeing a comet doing ordinary comet things in a way that looks strange because of geometry, resolution limits, and processing? Or are we seeing a genuinely unusual outgassing pattern that would look unusual even under independent instruments? Ray's dataset, as presented here, cannot answer that by itself. There is no chemical confirmation, no measured rotation rate, no independent replication, no calibrated brightness analysis. And the observation window, even across 2 nights, remains short. So the honest ending is uncertainty. Ray has provided a set of images and a workflow. The images are intriguing. The workflow is explainable. The interpretation is not settled. The next step is not belief. It's more data, more replication, and a tighter chain between raw frames and final claims.